Hello there. So this is my Hay Budden Anvil. I don't know if you can see that. There we go. 117 pound. Got it off of the family farm. It's pretty old. I think I saw somewhere that Hay Budden went out of business by about 1909. Can't see how old this might be. Anyhow, the top plate's broken off, as you can see. And what I've been trying to do is rebuild the top plate here. So originally that top plate was what they called crucible cast steel. It was forge welded to the anvil body, which is wrought iron, and they heated the whole thing up to sufficient temperature for welding. They put something similar to borax in between the two. They laid the top plate on there and used a press or hammers or something. You can kind of see the top plate there to forge weld it to the body. I don't have the means to do that here, so I kind of cleaned up what I had left of the top with a grinder, and I've been laying down 70-18 welding rod to build what some people call a buttering layer. And then that 70-18 rod I've been work hardening by beating with a hammer. So first I stress relieve the rod after I lay it down with this ball peen hammer, about a 2-pound hammer or something, and then I step up to this 4-pound hammer to just work harden basically the steel. I'm using a method that is kind of, I don't know, different people call it different things, but you call it a cold method or a minimal heat input method. So basically I'd only run about 4 1/8-inch rods on this at one time, and that's with having the anvil body at basically ambient temperature, and that'd bring the anvil up, make it pretty hot but not too hot to touch, and then just stop there and stress relieve the weld. The idea there is that you don't want to heat the anvil too much, because you'll cause the steel you laid down to crack away from the anvil, or you'll cause stresses that'll cause other problems. So you want to relieve that by beating on it as soon as possible. And then I was using the hammer to basically work harden the steel anyway. You can actually feel the difference. See, that hammer actually has some bounce to it. When you first lay down a fresh bead on here, that hammer hits actually with a pretty flat thud, and you can definitely feel it harden up. I'm going to try and take some shots of beating on some fresh beads. But then the idea is when this is done, kind of grind it off and clean it up to where I can then lay this down. This is a different type of welding rod, Ranite M. This is a surface hardening rod. This isn't the hardest one they had, because the hardest one was something like 63 Rockwell hardness, and the guys at the welding supply outfit told me that probably wouldn't have a lot of luck grinding that. So this Ranite M is actually specifically designed as a work hardening type hard surfacing rod. So it goes down something like 43 to 45 hardness, or 45 to 49, I can't remember. And then as it work hardens, it'll go up to like 54 or better Rockwell hardness. And so I assume between what it lays down at and what it hardens at, I'll kind of experiment with it and figure out the best way to grind it to the shape that I want, and then finish it out, make this anvil useful again. I know a lot of people say that there's really no sense in trying to repair an anvil, and you know, basically it's just should be left as it is, as a large piece of yard art. But I kind of figure, doing what I'm doing, if it doesn't work, I still have a large piece of yard art, and if it does work, I have a somewhat useful anvil here. So, and I guess I've just been using 1/8-inch electrodes, so the 70-18 is 1/8-inch and the Ranite is 1/8-inch. Just using an old Dayton stick welder. It does have DC output, 250 amp welder, but really I've only needed it at, I think I'm running 130 to 140 amps, DC electrode positive, and does a pretty good job laying it down. Okay, I just ran some more rod onto here. Originally I thought I was going to have us all in real nice neat lines and clean and straight, and it was, and as I keep going though, it just keeps getting uglier. So now I just go around looking for low spots and areas where it looks like it needs some build up. And these corners and edges definitely could use some build up. So there's what it looks like under the slag as you get the slag chipped away. But because I'm interested in stress relieving this, I'm only going to chip a little more of this slag away, and then I'm going to hit it with the hammer. Okay, I've chipped lots of the slag away here, gone over it with the brush. I just want you to see what happens to the steel with a big heavy hammer. So you can see these couple of beads right here. See if I can hit those. So I've beat on this for a while with that 4-pound hammer. So you can see all those newer beads I'd put on have now been mostly flattened. It definitely needs more. I just gauge the amount of hammer rebound to decide when I think I'm done beating on it. So once I get this pretty well filled in, I'll grind it and look for any low spots or voids or areas that need more material. We'll fill it in and work harden it some more. And once that's all done, I'll grind it nice and flat and smooth and square, and start putting the hard surfacing rod on it. By far the most intensive part of this project has been all of the hammering. You spend about 5 minutes of welding, about 25 to 30 minutes of hammering. You can tell that spot there needs to be filled in a little more. You can tell when you're hammering as this starts to harden up, because the hammer will rebound quite a lot more than where it's still soft. You can feel it in the hammer blow right away. I've got my ear protection back on, and so I'm gonna bounce this hammer around on the anvil for you so you can see the rebound. I'm gonna hold the hammer by the back end of the handle pretty far out. This. You'll see it's not going to take a lot of effort for me to swing it. It just rebounds on its own once that metal gets hard. Some of the spots up here are still a little bit soft. There's just some hard areas and some softer areas on here right now. here's the steel cap on the anvil. And here's an uncapped portion. So already, the steel I've laid down is hardened to a point harder in this uncapped area. Some areas anyway. And almost as hard as this capped area. So this might work out. We'll just have to wait and find out.